Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook. This one question cost marks on more papers than any other last year. Students muddled whether a quadratic had 2 roots, 1 root, or none at all, and lost easy marks doing so. Here's the promise. Calculate b squared minus 4ac, make a short statement, and that confusion disappears. Sound familiar? The concept. First principles. For a quadratic, ax squared plus bx plus c equals 0, the discriminant d is b squared minus 4ac. You might recognize it inside the quadratic formula. X equals minus b plus or minus square root of b squared minus 4ac all over 2a. That square root controls everything. If what's under it is positive, we take 2 different square roots and get 2 distinct real roots. If it's 0, both signs give the same root and we get a single double root. If it's negative, the square root isn't real and there are no real roots. Simple rule. D greater than 0, 2 real roots. D equals 0, 1 real root double. D less than 0, no real roots.
Now, 4 short worked examples so you can hear what to write and why it earns marks. Example 1. X squared minus 5x plus 6 equals 0. Here, A is 1, B is minus 5, C is 6. Calculate D equals minus 5 squared minus 4 times 1 times 6 equals 25 minus 24 equals 1. D is positive and a perfect square, so 2 distinct real roots, and we can factorize quickly to x minus 2 times x minus 3 equals 0, giving x equals 2 and x equals 3. That's efficient and tidy on the paper.
Example 2. 2x squared plus 4x plus 2 equals 0. A is 2, B is 4, C is 2. D equals 4 squared minus 4 times 2 times 2 equals 16 minus 16 equals 0. D equals 0 means a double root. The quadratic touches the x-axis at one point. You can give the root as x equals minus b over 2a. Here x equals minus 4 over 4 equals minus 1. Make the statement. D equals 0, so 1 real double root, x equals minus 1. Example 3. X squared plus x plus 1 equals 0. A is 1, B is 1, C is 1. D equals 1 minus 4 equals minus 3, which is negative. That tells us there are no real roots. The parabola sits entirely above the x-axis if A is positive. Instead of forcing messy algebra, write D equals minus 3 less than 0, so no real roots. Sketch shows curve does not meet x-axis. That statement alone often wins method credit when the mark scheme asks for the nature of the roots.
Example 4. 3x squared plus 2x minus 1 equals 0. Compute D equals 2 squared minus 4 times 3 times minus 1 equals 4 plus 12 equals 16. Positive and a perfect square again, so 2 real rational roots. Use the quadratic formula or factorize. X equals minus 2 plus or minus 4 over 6, giving x equals 1/3 and x equals minus 1. State your D calculation first, then show the formula substitution. Examiners like that order because it shows the decision process.
The exam technique. Exactly what picks up marks. For a discriminant question, examiners usually allocate marks like this. M1 for correct substitution and evaluation of D, M1 for the correct method to find roots or conclude their nature, and A1 for the final answer or statement. So even if you can't finish the roots, writing D with your arithmetic can capture that first mark. A short model sentence to copy onto the paper. D equals b squared minus 4ac equals. Since D greater than 0, or equals 0, or less than 0, there are 2 distinct real roots, or 1 double root, or no real roots.
Therefore, use factorising, quadratic formula, or sketch as appropriate.
Common traps to avoid. Arithmetic slips when calculating b squared minus 4ac. Always show the intermediate subtraction. For example, write 25 minus 24 equals 1. Don't forget the sign of b when squaring. Write minus 5 squared so markers can follow your working. Also, avoid saying no solution when d is less than 0. Prefer the phrase no real roots. That precision matches what the mark scheme expects. Write it down, don't just think it.
The quick win, a checklist you can run through in every quadratic question. 1. Calculate d first and write it on the paper. 2. If d greater than 0 and d is a perfect square, try factorising immediately. 3. If d equals 0, state one real double root and give x equals minus b over 2a. Sketch the vertex touching the x-axis. 4. If d less than 0, state no real roots and sketch a parabola not meeting the x-axis. Final step. Always substitute one root back into the original equation as a 10-second check to catch careless errors. Don't skip the check. Quick demonstration of that 10-second substitution check. If your root is x equals 2, put x equals 2 into ax squared plus bx plus c and confirm it equals 0. If it doesn't, retrace your arithmetic. That small habit catches around 90% of sign and calculation mistakes and can turn a lost mark into a gained one. Marks are there for the taking. Let that sink in.
News recap. Exam report. Examiners repeatedly flag two recurring errors in their reports. First, students solve and give numbers, but forget to state the nature of the roots. Second, arithmetic on b squared minus 4ac is done in the head and is wrong. Both are avoidable. Using the discriminant as your first step and writing the calculation clearly recovers marks even when solving the roots is messy. Examiners love that clarity.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and a downloadable discriminant checklist at jcacademyonline.co.uk. Go and grab the PDF after this episode.
Outro one-sentence recap. Calculate d first, state what it tells you, then choose factorising, formula, or sketch. Stay curious. Until next time, trust the process and nail that exam.